Good morning, everyone. Welcome back to Math Concepts. In this video, we are going to discuss some applications of sets. So you'll remember the reason we're discussing set theory is to give you an example of a mathematical structure that is different from the usual structure of arithmetic that you're familiar with from high school and even grade school. Okay, so we've talked about operations on sets. In particular, we know how to take the complement of a set. If I give you two sets, you can find the union and you can find the intersection. So those are the operations of sets. And in this video, we're going to talk about how to use those ideas in relation to counting sets of things. And sometimes it's going to be indirectly counting the sets of things. So let's go to the document camera and work on some examples of these applications of sets. Okay, so if you look on WebAssign in the textbook, you'll see we're in section 2.4. And the key ideas for this section are how to relate these quantities. And I suppose we would also need this quantity. Okay, so this little notation here is n of A is number of things in A, or if you want to use the appropriate vocabulary, this is the cardinality of the set A. Okay, so we'll talk about the relationships between these quantities, and we'll also talk about how to apply Venn diagrams to this counting business. So let's look at this example right here. Okay, so we're going to imagine that they surveyed 200 students. And this is one of those check all that applies surveys. So it has, do you like basketball, do you like volleyball? Those are the two questions in the survey. 140 people said they like volleyball, 120 people said they like basketball, 85 said they like both. So these are the questions that we're going to try to answer. Okay. Now, to help figure out this answer, I'm going to use a Venn diagram. Okay, in fact, maybe I'll draw the Venn diagram right up here so it's right next to the information. Okay, so as always, we have a box representing the universal set, and then we have two circles. Okay, so I know I only need two circles in this case because they're talking about volleyball, basketball. So this will be a V, and that's a B. V for the students that like volleyball, B for the students that like basketball. Now they tell me 85 students like both volleyball and basketball. So that 85 goes right there. You remember this region represents the overlap between the two sets, and if 85 people like both, 85 students should go in the overlap. Now, I'm going to write down something that's incorrect. Okay, some people might say, okay, you put 140 there because 140 like volleyball. That's not right. Okay, the entire circle for V has to contain 140 students. And we have already accounted for 85 students right there. Okay, so let me do a little scratch work here. If I do 140 minus 85, well, 140 minus 80 would be 60. Right, yeah. And then take away 5 more, so that'd be 55. Okay, so 55 students right there. So the total of these two numbers has to add up to 140. Okay? So the 140 students that like volleyball already contained the 85 that like both. So there's 85 here, 55 here. And we know that should be a 55 because these two have to total to be 140. And similar reasoning, these two have to total to be 120, so that should be 35. Do 120 minus 85 to get that. Okay. Now some more scratch work down here. I've got to figure out the number of students out here. Okay, because they told me there were 200 students surveyed, and it's possible that students didn't check either box. So let me total out what I've got so far. That's 140. 140 plus 35 is 175. So there should be 25 out here. Okay, so if I take all the regions in the diagram, it gives me 200. Okay, so, and the reason I'm getting 200 is because the reason I'm getting 25 here is 55 plus 85 plus 35 is 175. The entire diagram has to account for all 200 students. All right, so now that I've got my Venn diagram filled out, and a hint that I would give you here is that when you're filling out these Venn diagrams, always start with the overlap and then work your way out from the overlap. Okay, so in other words, I'm like starting at the bottom of this and going back up. Okay, now I can answer these questions. How many people like volleyball but not basketball? That's those 55 students right here. That's the 55 people that are in the volleyball circle but away from the basketball circle. How many people like basketball but not volleyball? 35. And finally, how many do not like either? That would be the 25 people that are outside the circles. Okay? So, the basic idea is that if I take the number of things in the union of the two sets, the number of things in the volleyball plus the basketball, okay, you're tempted to say, well, that's the number of people in volleyball plus the number of people that like basketball, okay, but that's not true. You've got to account for the overlap, okay, so the number of people in the union is equal to the number of people in each set individually minus the overlap. Okay, so this is the relationship between the quantity in each set and the quantity in the union. Okay, you've got to sum up each individual part and then take away what's in the intersection. I do want to look at one more example where we just kind of do this with numbers rather than an applied problem like this. So let's go and change over to that. Okay, so in this example, they're telling us the number of things in A, the number of things in B, and the number of things in the union. They're asking us to find the overlap. All right. So I'm going to do this problem two ways. I'm going to use the formula that we just discussed, which said the number of things in the union of two sets is equal to the sum of the number in each set individually minus the overlap. Okay, so this is a relationship between all four quantities, and from the given information I know three of them. So that's a 41, that's a 15, that's a 32, and this is an unknown. Okay, so right here, 41 equals 15 plus 32 minus, and I'm just going to kind of leave this blank for right now. So on the right hand side, right now I have 47. I want the total to be 41, so this should be a 6. So the number of elements in the overlap would have to be 6. Okay, and I can kind of check my work by filling out a little Venn diagram right here. Okay, so A and B. Okay, so that should be a 6 because we just figured out the overlap. Alright, now I know the number of things in A has got to be 15, so there must be 9 elements in here, right? Because remember, these two numbers have to total out to be the number of things in A, which is 15. And these two regions have to total out to be 32. So that must be a 26, because 26 and 6 would give me the 32. And if I add up everything I've got, 9 plus 6 is 15, plus 26 is 41. Okay, so these numbers do work out to be what they should. Okay, so the key ideas for this section, the key takeaway here, is relating the number of things in the union to the number of things in each individual set minus the overlap. Okay, that's an important principle. Okay, we're going to have another video where we do a couple more examples of survey problems and filling out Venn diagrams like this.